The universe shatters in a single frozen breath. A supernova caught at the exact moment of explosion. Its fire suspended like crystal shards in a void of stillness. Imagine a cosmos where the engine of reality, time, has been switched off. No before, no after. Only an endless now that stretches into infinity. What becomes of matter when it can no longer move? What would a universe frozen in a single instant look like? Stay with me, because the answer will reshape how you have ever gazed at the night sky. Time, as we understand it, is the fourth dimension, inseparable from the three dimensions of space. Together, they form the fabric known as space-time, a continuum that bends and stretches under the influence of mass and energy. In every experiment, every observation, the flow of time is the silent pulse that carries light, gravity, and change. Our hypothesis today is simple yet profound. If we were to remove that pulse, what would remain? Would the cosmos dissolve into a static tableau, or would something else emerge from the silence? We will travel through 4 stages. First, we will examine the geometry of a static cosmos, where light cannot travel and the universe becomes a network of fixed colors. Then we will confront the silent giants, crystal stars, and mute black holes that would dominate such a landscape. Next, we will explore the paradox of entropy, the battle between order and chaos when change is impossible. Finally, we will ask whether reality itself might already be a frozen photograph, a layer we are only now beginning to scan. Without time, light loses its ability to propagate. A photon, once emitted, would never travel beyond the point of its creation. Visualize galaxies as fixed, diamond-like sculptures, each star a facet catching an eternal glint, each spiral arm a frozen curve of luminous crystal. The night sky would become a 3-dimensional portrait, every point of light captured in perfect detail, yet no motion to betray distance or depth. In this scenario, the metric that describes space-time collapses into a static geometry. The equations that normally tell us how distances change with time become frozen, leaving only a spatial lattice. If photons cannot move, how can we even see these structures? Think of a photograph taken with an infinitely long exposure, where every star's light is recorded at once, but no subsequent change ever occurs. The image would be complete, but it would also be the whole story. No beginning, no ending, just a single frame stretched across eternity. This brings us to the silent giants that dominate any cosmos, black holes and the stars that would become crystal. Imagine a star whose nuclear furnace has been halted, its plasma locked into a perfect lattice of photons. No convection, no flicker, just a translucent sphere that glows with a steady, unchanging light. Now picture a black hole stripped of its temporal pull. In our universe, gravity is a curvature of space-time that tells matter how to move over time. Remove the time component, and the blackness remains a static curvature of space alone, a sphere of absolute darkness that does not devour, but simply exists as a perfect void. In this timeless realm, the force of gravity loses its ability to act, because there is no when for attraction to occur. The consequences are both beautiful and unsettling. A universe without time is a perfect photograph, an eternal preservation of every color, every shape, frozen at the moment of creation. Yet it is also a dead canvas, devoid of the processes that give rise to life, to evolution, to the very notion of existence. As we move deeper into this thought experiment, we will confront the paradox of entropy, the ultimate measure of disorder, and ask whether a world without change can ever truly be called a universe. If this is blowing your mind, hit that subscribe button and let's keep exploring together. Now, let us confront the paradox that lies at the heart of a timeless cosmos: entropy. In the familiar universe, entropy is the relentless tide that carries order toward disorder, that drives stars to burn, that makes mountains erode, that turns vibrant nebulae into faint wisps. It is the arrow that gives meaning to the words past, present, and future. Remove the dimension of time, and that arrow loses its very axis. Without a when, there is no how much change, and therefore no progression from low to high entropy. The universe would become a perfect tableau, each particle locked in a configuration that never degrades, each photon suspended photon-like, its wavelength forever unaltered. Imagine a nebula whose brilliant gases retain their saturated hues for an eternity, never diffusing, never cooling, never collapsing into new stars. Visualize a crystal star whose interior lattice of light remains immaculate, never succumbing to the inevitable nuclear fatigue that would, in our reality, turn it into a white dwarf and eventually a cold, dark remnant. In such a static setting, the concept of decay becomes meaningless, and with it, the very engine of evolution. Life, as we understand it, depends on gradients, differences in energy, temperature, concentration, that can be exploited over time. In a universe where every gradient is frozen, the potential for chemistry to dance, for organisms to adapt, for consciousness to arise, evaporates like a mist that never condenses. This perfect preservation is, paradoxically, also a profound emptiness. A photograph captures a moment, but it cannot convey the story that unfolds before and after the shutter clicks. A frozen cosmos captures every color, every shape, every structure, yet it tells us nothing about the processes that birthed them, nothing about the forces that would have moved them, nothing about the future that will never arrive. It is a masterpiece of stillness, a museum-like display of the universe's most exquisite artifacts, but it is a museum without visitors, a gallery without the footfalls that give life to the art. The question then arises, can a reality that is entirely static still be called a universe? Some philosophers and theoretical physicists have long argued that time may be an emergent property, a construct of consciousness rather than a fundamental ingredient of the cosmos. In certain approaches to quantum gravity, the equations that describe the fabric of reality do not contain a time variable at all. They describe a timeless wave function of the universe that encodes all possible configurations simultaneously. From that perspective, what we experience as the flow of time could be akin to a film reel being projected, each frame already existing in a vast timeless archive, and our minds simply moving from one frame to the next. If that is the case, perhaps the universe we inhabit is already a kind of frozen tapestry, and what we perceive as change is merely the unfolding of a pre-written script within a higher dimensional arena. Some theories of extra dimensions suggest that our familiar four-dimensional space-time is a slice of a richer, multi-layered structure. In those higher layers, the notion of before and after might be replaced by a different kind of ordering, one that does not rely on a single temporal axis. It is conceivable, then, that the static picture we have imagined is not a hypothetical alternative, but a glimpse of the deeper reality that underlies our everyday experience. Consider the analogy of a book. The pages are fixed, each bearing ink that never moves, yet the story emerges only when a reader turns the pages in a particular sequence. The pages themselves are static, but the narrative is dynamic, living in the mind of the observer. If the universe were a bound volume of all possible states, the act of observation, perhaps the emergence of conscious agents, could be what gives rise to the illusion of temporal flow. In that sense, the now we inhabit is a point of focus, a spotlight that illuminates a particular configuration while the rest remains in quiet suspension. This line of thought invites a profound philosophical reflection. If time is a construct of perception, then the ultimate fate of the cosmos may not be a heat death or a big rip, but simply the cessation of the processes that generate the perception of change. A universe without observers would be a silent, immutable tableau, its beauty forever locked in a single, unchanging frame. Conversely, the very act of observation could be the catalyst that breathes temporal breath into an otherwise static existence. What does this mean for us, the curious minds peering into the night sky? It suggests that the urgency we feel to understand the origins and destiny of the cosmos may be rooted in a deeper yearning to comprehend the nature of our own consciousness. If the flow of time is indeed an emergent illusion, then exploring its foundations is tantamount to exploring the foundations of self. The cosmos, in its frozen grandeur, becomes a mirror, reflecting the limits and possibilities of perception itself. Now, I invite you to pause and let this idea settle. Imagine you could freeze the universe at a single instant and hold that moment forever in your mind's eye. Which phenomenon would you choose to observe? Would you linger on the delicate filaments of a distant galaxy, the swirling arms of a spiral that would otherwise spin for billions of years? Or would you focus on the heart of a supernova, its brilliant core captured at the exact moment of cataclysm, its light forever unspent? Perhaps you would select the quiet darkness of a black hole's event horizon, a perfect sphere of void, that, in this timeless scenario, no longer devours but simply exists as an absolute absence. Your choice reveals something about the aspects of the universe that most captivate you, about the balance you seek between beauty and mystery, between motion and stillness. Share your selection in the comments below. I am eager to read which frozen marvel you would cherish for eternity. If this journey through a static cosmos has sparked your imagination, consider supporting the channel by liking this video and subscribing if you haven't already. Your engagement fuels the exploration of these deep questions, and together we can continue to peel back the layers of reality, one thought experiment at a time. In closing, remember that the universe we inhabit is a tapestry woven from both change and constancy. The relentless march of time gives shape to galaxies, life, and thought. Yet the possibility of a timeless backdrop reminds us that the very fabric of existence may be more intricate than our senses can grasp. Whether time is a fundamental river or a fleeting illusion, the quest to understand it remains one of humanity's most profound adventures. Keep questioning, keep wondering, and let the endless now inspire you to look beyond the horizon of what seems possible.